Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions for AP Physics 1. In this lesson, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together. Let's improve together. Question says, a spaceship and its shuttle pod are traveling to the right in a straight line with speed v as shown in the top figure above. The mass of the pod is m and the mass of the spaceship is 6m. The pod is launched and afterward the pod is moving to the right with speed vp, and the spaceship is moving to the right with speed vf, where vf is greater than v. As shown in the bottom figure, which of the following is true of the speed vc of the center of mass of the system after the pod is launched? So in this case, we need to understand when velocity of center of mass of a system will change. Velocity of center of mass only changes if there is net external force acting on the system. As in this case, there is no net external force acting on the system before and after launching the pod. So in this case, velocity of center of mass has to remain constant. And velocity of center of mass before launching was equal to v, because spaceship is moving with that speed. And velocity of center of mass after launching pod also has to be equal to v. So it simply means that velocity of center of mass is equal to v. So the answer for this question has to be D. So D is the answer. So you need to understand delta VC is equal to 0 if no net external force acting on the system. If no net external force acting on the system. So this is the point you need to understand. Acting on the system. So this is the key concept which you need to understand. Acting on the system. Delta VC is equal to 0 means velocity of center of mass does not change if no net external force is acting on the system. Question 34 says the diagram above shows a top view of a child of mass capital M on a circular platform of mass 5m that is rotating counterclockwise. Assume the platform rotates without friction. Which of the following describes an action by the child that will result in an increase in the total angular momentum of the child platform system? So for this question, we need to understand is there any net external force acting on the system or not? As in this case, it is given to us that there is no friction. So it means that there is no net external force acting on the system. So simply we can say in this case F net on the system is equal to 0. So we are talking here for the system. So for the system, F net is equal to 0. If F net is equal to 0, it means that tau net is also equal to 0. If tau net is equal to 0, it also means that change in angular momentum is also 0. So we can say delta L in this case is also equal to 0. Means angular momentum remains constant. So in this case, if the child is moving towards center, our child is moving away from the center, our child is moving along the circle, concentric circle. In all these cases, total angular momentum of the system will not change, but the momentum of the child will change, or momentum of the platform will change, but total angular momentum of the system will not change, because in this case there is no net external force acting on the system. So answer for this question has to be D. None of the actions described will change the total angular momentum of the child platform system. As there is no net force, so there is no net torque. If there is no net torque, it means that angular momentum of the system remains constant. Question 35 says a train is traveling east with constant speed Vt. Two identical spheres are rolling on the floor of one train car in the frame of reference of the train in the frame of reference of the train, the spheres are moving directly towards each other at one instant with same speed vp. Mean these two spheres, they have the same speed vp. So simply we can label this one, they have same speed vp, and the speed of the train is given to us, that is vt. So this is speed of the train with the same speed vp parallel to the train's motion as shown in the figure above. What is the velocity of the center of mass of the spheres in the frame of reference of the train and in the frame of reference of a person standing at rest alongside the train? So first of all, we need to understand in frame of reference of train. So we can write down in frame of reference of train, reference of train, frame of reference of train. So as in this case, these two spheres are, they're moving towards each other with constant speed and they're moving opposite, so their center of mass will stay at rest. So center of mass, we can say velocity of center of mass in this case will be equal to 0 because they are moving with constant speed in opposite direction. So if the center of mass is at the center, we can also label here is here, so center of mass will stay here, so its velocity will be equal to 0. Now we can try to understand this one in frame of reference of person, in frame of reference of person standing outside of the train, frame of reference of person standing outside of the train. According to that person, as velocity of center of mass of the sphere in frame of reference of train is equal to 0, so the velocity of sphere, center of mass of sphere in frame of reference of person has to be equal to the velocity of the train. So in frame of reference of person, velocity of center of mass will be equal to the velocity of the train to the east. Velocity of the train means train is moving to the east, so it has to be equal to that. So we can also say in this case, velocity of center of mass with respect to ground, with respect to person, or simply we can say this one has to be equal to velocity of center of mass with respect to train plus velocity of train, we can say velocity of train with respect to the ground, velocity of train with respect to ground. So in this case, velocity of center of mass with respect to train is equal to 0, and velocity of train with respect to ground, velocity of train with respect to ground in this case is equal to vt. So this is velocity of train. So in this case, velocity of center of mass with respect to ground, this is simply equal to vt. So velocity of is equal to vt, and this is to the east. So the answer for this question has to be B, 0 with respect to train and vt with respect to person. So the answer for this one is B. Question 36 says a satellite that is a spinning cylinder has initial rotational inertia I naught and angular velocity omega naught. Solar panels unfold from the satellite and are extended outwards. The satellite then has rotational inertia if is equal to a I naught and angular velocity omega f is equal to b omega naught, where a and b are constants. Which of the following is true about constants a and b? So in this case, you can simply imagine that first of all, satellite is like a fist and then it is extended. As satellite is extended, so more mass is away from the center, so its moment of inertia increases. So we can say if in this case increases, if increases, and if is greater than I naught. As if is greater than I naught and if is equal to a times I naught, so a has to be greater than 1. So A has to be greater than 1. So this is one thing we can understand. And the second thing we need to understand, as in this case there is no net external force acting on the satellite, so angular momentum remains constant. So delta L is equal to 0. It simply means that I naught omega naught angular momentum, delta L is representing angular momentum, so there is no change in angular momentum. So we can say I naught omega naught, this is equal to IF omega F. As in this case IF has increased, so omega F has to decrease to keep angular momentum constant. So it simply means that omega F in this case is smaller than omega naught. So we can say in this case as omega F, this is equal to B times omega naught, so B has to be lower than 1. So this is B has to be lower than 1 because omega F is lower than omega naught. So A has to be greater than 1 and B has to be lower than 1. So the answer for this question has to be B. A has to be greater than 1, B has to be lower than 1. So the answer for this question is B. Question 37 says, when the circuit shown above is set up, the potential difference across the battery is 3.0 volts. By how much will the magnitude of potential difference across R2 changes when R3 is removed and its branch is left open? So first of all, in this case, we will try to find out what is value of potential difference across R2 when R3 is connected. So we can simply say this one is V1. This is V1. And then we will try to find out when this branch is disconnected, what is value of V1 prime. We can redraw this circuit. So first of all, we can redraw this circuit. So we have one cell, this is 3.0 volts, and we have one resistor here. As these two resistors, they are connected in parallel. As they are connected in parallel, so the total resistance R total of these two resistors connected in parallel simply will be equal to R2 multiplied by R3 divided by R2 plus R3. As in this case, R2 is equal to 100 ohms, R3 is also equal to 100 ohms. So here we have 100 plus 100. So in this case, simply we have, this is 100 multiplied by 100 and divided by 200. So simply we can say this is 100 multiplied by 100 and this is 2 multiplied by 100. So 100 and 100 will be cancelled, and total resistance of these two resistors in parallel, this is equal to 50 ohms. So this is equal to 50 ohms. We no need to do this whole process. Simply you need to understand, if resistors are identical and they are connected in parallel, then total resistance simply you can calculate. You can take the resistance of one resistor and you can simply divide by number of resistors. As in this case, resistance of one resistor is 100 and we have two resistors in parallel, so the total resistance in this case of these two resistors is equal to 50 ohms. So this is how you can calculate, but you can also use this method. So we can replace those two resistors with one single resistor. So this one is 100 ohms, this is R1, and this is over R total, we can say RT, and this one is equal to 50 ohms. So we have to find out what is value of V across this one, because the PD across R3 and R2 is the same. So if we need to find out V across this one, so we can say this is V1. V1 has to be equal to the resistance of this resistor, that is equal to 50 divided by total resistance of these resistors in series. This formula you can only use if the resistors are connected in series. So we have the resistance of this resistor divided by total resistance, means we have 50 plus 100, and we have to multiply this one with potential difference across these resistors in series, that is equal to 3 volts. So this is 3.0 volts. Now if we simplify this one, we have here 50 and this is divided by 150. I'm just writing these things in detail, but if you are very clear about this one, this question can be done in just one step. So from here we can cancel, so we will get here this is equal to 3 and we will cancel, so we will get 1. So this is 1.0 volts, so value of V1. So we have got value of V1 when these 3 resistors are working properly in the circuit. Now we have to remove this 1, and so we can redraw our circuit. So we can redraw circuit. So simply we have, this is 3 volts battery and we have one resistor, that is R1, and its resistance is equal to 100 ohms, and the second resistor we have R2 and its resistance is also equal to 100 ohms. This is 3.0 volts. 3.0 volts. As two resistors, they have the same resistance and they are connected in series. It means PD across this one has to be equal to, we can say this is V1 prime. So this one has to be equal to 1.5 volts. 1.5 volts, we can say V1 prime. This has to be equal to 1.5 volts. Now simply you can say the potential difference across R2 has been increased by 0.5 volts. So it has been increased by 0.5 volts. So this delta V has been increased by 0.5 volts. So the answer for this question has to be the magnitude of potential difference decreases by, this is wrong, doesn't change, this is wrong, this is telling us increases by 0.5 volts. So the answer for this one has to be C. So this is how you can approach, but if you wanna use this formula to calculate, you can also use the formula. You can say in this case V1 prime, this one has to be equal to the resistance of this resistor, that is equal to 100, divided by total resistance, that is equal to 200, multiply by the resistance across these resistors, potential difference across these resistors, that is equal to 3.0. Now if we solve this one, we will get this is 1.5 volts. So this is also, you can use this formula, you can calculate. So the answer for this question has to be C. Very straightforward question. I just did this one in detail, but if you have clear understanding of circuits, you can just look at the question and you can find out the answer. Question 38 says two wave pulses are propagating along a straight line toward each other as shown above. Which of the following is the resultant when the centers of the pulses align? Centers of the pulses align. So in this case, when these two waves meet, what is the resultant wave? So for that purpose, we can simply first of all redraw these two pulses. So we have one pulse here, so this is one pulse where they align, their centers align. So we can draw the second pulse here. So we can draw the second pulse. So this one is the second pulse. Now simply we need to add these two pulses. If you look at this point, the red one, it has 0 displacement, and blue one, this one has this much displacement. So we can see this has positive displacement. So this is the positive displacement. Now if you look at the center point, we can use two different colors. This one has negative displacement, so this is negative, and the top one, this has positive displacement, but they have same magnitude and they are in opposite direction. So the resultant displacement has to be 0. So this point has to be at 0. We can also take another point. Let's say we take one point here. So we can draw the arrow from the equilibrium. So this is negative displacement, and we have the positive displacement, that is here. So in this case, positive displacement is greater, so it means that the resultant displacement is somewhat here at this point. The same will be true here. If we repeat the same process, it will be here. Now simply we need to connect these points. So we have displacement here, so it will look like this, and at this point also displacement is positive. At this point also displacement is positive. Simply you need to add these arrows, and here it will come to this point. So this is the resultant. So red one is the resultant. Now we can clear rest of them, so we can clear them. So here if we clear, so this will be the final shape. This will look like M. So the answer for this question has to be C. Simply you need to add like a vectors, and this will be the final shape. So the answer for this question is C.